sort of like that. So one more time. Standard notation uses decimals to describe a number. Scientific notation uses power of 10 to describe a decimal number. A number written in the form of mx 10 to the n, where 1 is less than or equal to m, but 1 is less than or equal to m, and m is less than 10, and n is any integer. Okay? So remember, when I'm writing out scientific notation, my numbers have to be greater than or equal to 1, but less than 10. Okay? So for this first one, I've got 8,000. Well, 8,000 is not going to work because that is not between 1 and 10. So I'm going to move my decimal place over 1, 2, 3. So I get 8 times 10 to the third, because I moved it 3 places. You guys, your notes are still required to be written down, so you should have written all of this down. Now we're going to look at number 2. I've got 3,456,000. So I need to write this in scientific notation. So I'm going to go to the end, and I'm going to move my decimal place over 1, 2, 3, 4, 5, 6. So I get 3.456 times 10 to the 6. Is this starting to make sense? As long as my number here in front of the decimal is between 1 and 9. And then how many place values I move over is my exponent by the 10. Let's try number 3. We've got 90, the sun is approximately 93 million miles from Earth. We're going to write this in scientific notation. Please take notes. I'll give you a pen. Okay, I don't care. All right, so we're going to move this over until it is between the 9 and the 3, correct? So we move it over 1, 2, 3, 4, 5, 6, 7. So it should 9.3 times 10 to the 7. Okay? Now, ladies and gentlemen, we're going to look at if we've got very small numbers. Okay? So we've got 0.0006. But we know in scientific notation, it's got to be between 1 and 9. So we're going to move it over 1, 2, 3, 4, and we get 6 times 10 to the negative 4, right? Because we're going in the opposite direction. We always use 10. It's just the formula that we're putting in there. Okay, so let's do the next one. We move that decimal place over 1, 2, 3, 4, 5, 6, 7. 7.92 times 10 to the negative 7. Does anybody have any question about those? We all understand that if we're trying to make it, if we've got a very, very small number, we are using negatives. Okay? All right, ladies and gentlemen, we are now going to do it the other way. We've got it in scientific notation, and we're going to make it into standard form. Okay? So if I've got 4.03 times 10 to the 6, is this going to be a very small number or a very big number? Big, because it's that positive exponent. So I get 4, and I'm moving the decimal place over 1, 2, 3, 4, 5, 6. Now I'm just going to make sure. 1, 2, 3, 4, 5, 6. Yep. And I can put a comma after every 3 numbers so that it's easier to read. Okay, let's look at the next one. Is this going to be 5.2 times 10 to the negative 5? Is this going to be a very big number or very small? Why is it going to be small? I'm not sure. Because it's a negative exponent. Good. So I know I've got to move it over 5 places. So I'm 1, 2, 3, 4, 5 with a decimal in front. Let me just make sure. 1, 2, 3, 4, 5. Let's try one more before we try some on our own. We've got 2.86 times 10 to the negative 8. Big or small number?
No, small.
Because it has what? A negative exponent. And it's got 8, so I've got to move it over 8 decimal places. So I think, okay, 1, 2, 3, 4, 5, 6, 7, 8. Let me just make sure. And there's a decimal place in front of it.
You put it in there. No, right there.
Thank you, Magic. 1, 2, 3, 4, 5, 6, 7, 8. 0.00000000286. Okay, we ready to try some on our own? Alright, ladies and gentlemen, let's do this last one. We are multiplying two numbers in scientific notation. So we're multiplying these two numbers. Alright, Chuck. Okay? So the first thing you're going to do, just like when they're in exponent form, scientific notation is the same way. I am going to multiply the two numbers in front. 4.2 times 2.31 gives me 9.702. Now I'm just going to add the exponents. 5 and 4 makes 9. Okay? So we multiplied the numbers in front of the x, and then we added the exponents by 10. Okay? All right.